don't take your old state standards out of their boxes and swap in the Common Core standards. They're meant as a platform for a new kind of instructional system. They're not meant to be a new list of topics for the old instructional system. This is very deliberate in the way that they were designed. We were told to base it on evidence, and a big part of the evidence was lessons learned from 20 years of accountability. And those 20 years of standards-based accountability systems, some good things have happened and some things are broken. And we tried to fix what's broken. In mathematics, many of the things that are broken are summed up in the phrase, a mile wide, inch deep. So where does a mile wide, inch deep come from? We're doing it to ourselves. Nobody's doing it. And when are we doing it? We're doing it when we turn standards into long lists. We're doing it when we tell teachers to cover instead of to teach. When we give them pacing plans, we tell them to cover everything on the test. Cover is a synonym for inch deep. We want our standards to be higher, which means deeper, not wider. So we shouldn't be worried about getting the width of the standards. That's what cover means. We should be worried about getting the depth. That's what learn means. And learning correlates with achievement, including achievement on standardized tests. And that covering does not. The highest scoring countries covered less than we did, not more. And so we tried to make these more focused and more coherent. That means less stuff. It also means the relationship among the standards matter and matter a lot. So the superstructure, the way standards are clustered, the pages that introduce each grade level are about the coherence and the focus of the standards. And they shouldn't be ignored. And the 8 practice standards hold them all together. That's part of the coherence. Don't look backward and try to relate these to the past. Look forward. In other words, no more crosswalking. Crosswalking is jaywalking. No more aligning. No more, all of that kind of stuff is paying attention to the wrong thing. That's breaking the standards down into pieces so you have an incoherent list of topics. That's not what they are. And we shouldn't be doing that with them. They're describing the picture as a whole and breaking it up into manageable parts. It's not just a collection, a list of topics. Standards are a piece of a much larger puzzle, as you're pointing out. And the difficulties are real, and the standards are not a magic pill. But that's what this workshop is about. So I want to go a little bit into what these Common Core standards. There's a website, corestandards.org. And that website, you can download the standards, which includes an appendix of high school, model high school courses, if you want to look at those. One of the advantages of many states sharing the standards is that people who develop stuff can develop stuff for a 40-state market. So there is now money going into places it didn't used to go to develop stuff for teachers. So it's not just making textbooks anymore. So there's going to be a lot more interesting web-based, software-based stuff being developed by people who didn't work in education before or invest. So you're seeing lots of interesting stuff will be coming out. So the standards themselves have 2 kinds of standards. One kind are the content standards you're familiar with, grade-by-grade standards. But the other kind are these, the mathematical practices standards. These are descendants of the NCTM process standards, adding it up 5 proficiencies, a lot of research into what mathematicians do and how students learn. You can see what the kind of things they are. Make sense of complex problems and persevere in solving them. They're on pages 6, 7, and 8 of the Common Core standards. And there's a paragraph or two defining each of them. What we did with these is take things that people liked but ignored. Everyone loved the process standards and everyone ignored them. And we tried to make them more mathematical. We tried to make them more closely related to the content standards. But if you look at these, the way we thought of them as a definition of mathematical expertise. And what we mean by that is a student starts as a beginner, then they're a novice, then they're an apprentice, and they become an expert. Expertise develops over time in complex ways. It's not just something you learn. It's the way you change as a person. It's the way knowledge comes together and gets used. It's attitudes, it's habits. And you notice, construct viable arguments and critique the reasoning of others. This assumes kids are talking to each other in class. We're telling principals and school districts, this is the basis for your relationship with teachers at the lesson level, not content coverage. And these are practices of students, not teaching practices. They have direct implications for teaching practices, but they're practices of students. So I urge you as a first step towards the Common Core standards to start with the practices, and as a group of teachers, figure out what commitments you'll make to make these practices sort of the center of the classroom culture. There's another way of looking at these, which has become more and more the way I think about them. These define the content of a student's mathematical character. These are like character. You don't, when you're trying to, you don't say to students when you're developing character, you don't say to kids, adults don't say to kids, oh, don't worry, sweetie, I wasn't honest either and I turned out okay. You don't say things like that. You don't say, I'm not an honest person, so excuse me from honesty. That's not how you develop character. You develop character by modeling it, by responding to it. Unfortunately, with FaceTime, with personal relationships. So we don't, it's not right for the English teacher to say, I'm not a math person. Wait a minute, didn't we just tell every kid in the school they're required to be a math person to graduate from high school? And it's okay for the English teacher to say, I'm not a math person? It's okay for the principal to say, it's not okay. The principal cannot say, I'm not a math person. It's okay to say, I have a lot of math to learn. I haven't learned as much math as I want to know. What does it mean to be a math person? It doesn't mean you know the math. This is what it means to be a math person. It's your attitude towards how you're going to learn math and how you're going to respond to math. So when we work with principals, we stress the importance of their personal leadership in the development of the kids' character by presenting themselves as math people, in that they want to learn math, they take this attitude towards learning math. This is the content of your mathematical character. And that's, to me, the basis of the relationship of leadership to teachers and students. Not what standard are you teaching today or covering. Content. So mile wide, inch deep, we didn't want to be part of that problem. So we tried to our goal was to attain focus and coherence. The Singapore website's banner says, teach less, learn more. The results, the only one we have for this are fourth grade that I know about. In the TIMSS, the International Comparison, the test has more than any country teaches, because they wanted to, if kids learn stuff, they wanted the kids to get credit, the nation to get credit. Singapore taught 45% of the topics on the TIMSS test, about less than half. They were the #1 performing. Hong Kong. Now, this is Hong Kong. The US taught 80% of the topics. They were among the lowest performing. So covering does not translate into test performance. The Hong Kong students got more depth on less topics and did better on this test than the US students who got superficial knowledge. And we know in mathematics that it's not until your understanding reaches a certain depth, which is deeper than we teach to, that it transfers. And it drives us crazy as teachers. They learn it in this context. Next day you give them a different context. It's like they didn't learn a thing. That means their learning was superficial. I mean, transfer is a task. I'm not pretending it's not. If they can get deeper, it transfers more readily. The deeper you go, the closer things get, the more coherent mathematics is. Focus also meant we left stuff out. States would look at our drafts and say, oh, you forgot about this. No, we didn't. We decided to leave it out. The other thing, the strands. This is where you get incoherence from being too general. So in grade 1 and a typical US standards, it looked like that. In grade 12, it still looked like that. To us, that was a source of incoherence. So we did things like this. We broke number into 3 different progressions. Operations and algebraic thinking, this is at K5. Number and operations, base 10, arithmetic, and fractions. And these 2 fed into the number system in 6th or 7th grade. And this fed into expressions and equations, and they both feed into algebra. So we had things like many of the high-performing countries that have a beginning, a middle, and an end. They're not K-12. So most states thought making strands that are K-12 was a virtue. We saw it as a menace. And so we have things have a middle and an end. There are really 3 main differences from what you're used to. One is the emphasis on modeling. And now modeling is not, it's one of the 8 practices I showed you, but at the high school level, including Algebra 1, it's an explicit standard. So you'll see things like modeling with exponential functions. And then you'll see them explain what we mean by that. So modeling is a real emphasis at high school. A second thing is there's a shift in geometry from a primarily Euclidean approach to a primarily transformational approach. And one of our motives for that, the main motive was that's the geometry that's actually used. But also, it's more closely and transparently related to algebra and functions. So that during geometry, we'll be keeping algebra alive in a meaningful way. But the third change relates to the discussion we were having earlier. And it's untangling solving equations from analyzing functions. Solving equations has been at the heart of Algebra 1 for a long time. And it goes back to the 19th century when we were preparing kids for a college course called Theory of Equations, which hasn't been taught in over a century, but we're still preparing kids for it. When calculus became the center of the curriculum at the university, we started adding functions into the high school curriculum without subtracting theory of equations. So we have a jumble. So it not only resulted in too much stuff, but it also resulted in a lot of confusion and real garble. And so we made an attempt to untangle the garble. In the way they do it in the Asian countries, which is the way we followed it, this idea of quantities in a situation, variable and function, come out of measurement. So if you look in our K7 curriculum, measurement morphs into, measurement deals with quantities, with units. The units become the variables. What's the variable in this section? Time in seconds. What's the variable? Distance in kilometers. It comes out of measurement. And that's what sets up functions in middle school. this quantity and measurement. And that's what ratio and rates and proportionality is all comes out of measurement. And this is a very science-oriented way of looking at it. And at the same time, we develop these expressions, but the different role of expressions and functions and solving the equations is an important way we untangled it.